BioHackathon. BioHackathon, where actually most of the steering council was there participating in a number of projects. So on the first slide, I've put the steering council members. I updated the last slide we had. Actually, one thing to note is we are still looking for someone from training. So this is an advertising slide and a membership slide. So there's me in charge of basically research infrastructure liaison, which is keeping an eye out on opportunities for bioschemas in work that's going on, particularly looking around at EOSC and things like that. So ELIXIR BioHackathon, it's a pretty much yearly event. I think there's something like 110 people in person. There's a link there to the Flickr site where there's some photos if you want to see who those people are. There's 35 projects. I don't know how many people were there virtually. I'm guessing like 70, something like that, but Gavin can put me right if I got it wrong. And the format basically is focused on hacking. We uploaded presentations before the start of the BioHackathon to let other people know what was going on. Midway through, there's a kind of an advertising or plea for help where you need some expertise that might be available. And then there's a final day reporting, and the links for all those slides are there. Bioschemas was involved directly in a number of projects and also indirectly, and I'll come to that in a second. So I've highlighted them there, and our project was number 23. So what I'll do now is I'll give you a brief overview of what we did based on what we presented in our slides at the event. And then Alban's going to talk a bit more detail about one of those activities. So we had basically 3 tracks of work going on. There's stuff around fairness, so looking at bioschemas and how it helps with fairness and doing assessments and things like that. There's a community thread, which we'll talk about, is basically interacting with other groups. And we had some ideas on what we wanted to focus on in terms of types and profiles. And we wanted to connect up our kind of user tools to enable people to more easily work with bioschemas. So the objectives were to analyze the usage of bioschemas and find a way to feed that back to improve its use. Types and profiles, as I said, a number of communities also are included in that. One of the improvements we wanted to make, which was to have fully resolvable URIs in our types and profiles. So some of those links were pointing to dead ends, essentially. And also there's another piece of work on schemas.science, sorry, typo, where we want to expose more visibly our domain agnostic work. So there's some of that still to do. So we have, based on some harvesting, automated harvesting of sites, we have some usage analytics. We need to look more carefully at that, try and find ways to feedback. There was some specific work on lab protocol and lab process with one of the other groups that was there. One of our focuses was on samples. So essentially there's a biodiversity community emerging within ELIXIR. It's one of the new community groups, and there's a number of projects working on diversity, and there's a need for biodiversity sample information. Our plan is to work from sample, which already exists, and improve that, and we have some ideas how to do that. And then from that, come up with profiles for different types of samples. So that includes clinical samples, biodiversity samples, and things like that. Some requirements emerged. We discussed with Stefan, who's on the call, defined term, and we have some steps to kind of address those issues. There's some steps we've identified for improving the code, which links bioschemas in DDE so that we can create types. And the other objective, of course, was to come up with a biohack archive report. So I've linked the report there, which is not progressed that much actually at the moment, and the day 5 slides. So our actions at the moment are to interpret the analytics and define feedback mechanisms. So that could be to resource owners or communities. We identified some steps. We need to assign people to those and some timelines. So that's lab process and lab protocol. We did a survey while we were there. We also have a bunch of information from EBI resources on the manifests and the metadata that they use. So we'll be doing an in-depth analysis of that and proposing how to move forward from sample to biosamples. Defined term and defined term set, which are, again, we need to assign some actions for that. Probably we could talk to Stefan while he's here. Schemas.science, DDE. I've noted here next to some of these actions, German BioHackathon. So we intend to do some of this work there. At this point, I'll hand off to Alban, I think.
Thanks,
Alban,
Nick.
do you want to do slides, or are you happy to do it?
Yeah, maybe I can say next slide. And
okay.
It's easier. Yeah. Okay. So thank you, Nick. So I'm Alban Gaignard. I'm member of ELIXIR France, and I'm involved in a Bioschemas steering committee on the tooling activities. The goal is to provide support tools to ease both the production and the consumption of bioschemas markup. And one thing I can say is that we have been also developing a fair evaluation tool, which is used in order to assess the quality of metadata annotations. It is also used to harvest and to extract bioschemas markup from web pages. So what we did in that part is that we try to analyze the contents of bioschemas markup for the whole live deploys URLs that we have in the bioschemas website. So I automated the process through a GitHub action, which is run weekly. So each week we have a script which uses FairChecker to extract all the bioschemas markup from the 140 live deploys URLs. So we end up with an RDF dataset of schema.org triples. And these datasets has the size of 74,000 triples. So based on that, we can do some queries in order to better understand what's inside these datasets. So next slide, Nick. Thanks. Okay, so the first query we set up was to try to understand what are the most used classes and properties. So on the right part here, we have a sorted list of schema.org classes, and what we can observe is that the most used class in all live deploy is creative work. And then we can see that we have biochem entities, data download, creative work. And then here you can see that we have some typo in the markup, because creative work is a class and it should be spelled with capital letter. Okay, that's it for the classes. And then we have the properties. So something to note is that we have a lot of properties for specifying the names or URLs, but we have too few of them to specify the conformsTo, which is the way of linking a bioschemas profile to an instance. We have only 500 properties for conformsTo, and we have 20,000 properties for named entities. So we should have much more in order to ease the validation of the markup. Also, line 8, we have an @type here, which is, I think it's a misspelling or a misuse of JSON LD markup, because we should have the first line for the use of RDF type. So this is something that we need to investigate. Next slide, please. Okay, so then we try to analyze the number of conformsTo properties, because this is very important, because if we want to validate bioschemas markup, then we need to get access to a bioschemas profile. And this is a way we defined to link an instance to a profile. So what we can observe is that we have more, let's say, live deploys without conformsTo rather than with conformsTo, which is bad news. But still, we can evaluate almost half of the live deploys with a validation tool. The second part of the figure, so I tried to evaluate the link between the number of triples and the fact that conformsTo property is provided or not. And we can observe that if you have more exposed triples, then you have more conformsTo, but it's a bit difficult to interpret. I'm not sure that we can say that much. Okay, maybe next slide. Okay, thanks. So now we have been trying to see what is the most used profiles. Again, it's based on our 140 live deploys. So the most used profile is a training material. Then we have person in the draft version of the profile. Then we have data catalog, dataset, organization, chaos instance, molecular entity, and so on. So this means that we have a lot of examples coming from the training community with training material, course, organization, and so on. Okay, then next slide, please. Okay, then so for all the live deploys with a conformsTo property, we were able to run fair checker in order to analyze the missing required properties or the missing recommended properties. So here we can see that so we analyze the number of errors, which means the missing required properties. And what we did with Nick is that we counted all the errors on the all live deploys, and we aggregated these errors by the profiles. So what we did in addition, because if you have a lot of examples per profile, then you may have a bias in the number of errors. So we just normalized the count of errors by the number of examples in the live deploys. So at the end, we end up with some profiles with most errors than the others. And for instance, so we have first the draft profiles. So I don't know if I'm not sure if we need to talk about that, but what is more interesting is the data catalog release profile, because it's something which is stable, which still have a bit more than one error per example. So this means that we could come back to the communities around the data catalog, same for computational workflow, and try to see with them how we could enhance the quality of their markup by fixing first the missing required properties. Okay, next slide. Thanks. Okay. So then we investigated the validation warnings. So by warning, we mean the missing recommended properties in the profile. This means that there is still room for improvement. So the message here would be we have good quality markup, but we can still increase the quality. And this is the case especially for the computational workflow, the course, and the organization. This is maybe because the profile is extensive and specify a lot of recommended properties. And when we evaluate this profile on some example, we have a good number of missing recommended properties. Okay, so so maybe Stuart, we can we could investigate that together on the workflow examples. Okay, so next slide. Okay, and this is the last slide. So for the previous analysis, we focused on the profiles, and now we go a bit more fine-grained, and we go to the granularity of properties. So we try to see globally on all the live deploys which properties, which required properties were missing. So we counted the missing required properties, and at the end we obtained that this is a URL property which is missing a lot. So we could try to see why this property is not filled. And if we fix that, we would then have a good impact on all the live deploys because they would validate validate evaluation. And same thing for the missing recommended properties. So this is the top 10 missing properties, and we have alternate name, citation is based on variable measurement technique, and so on, version. So we could also increase the quality of our metadata if we focus on these very few properties. So this is a way of maybe prioritizing our work if we want to increase the quality of our metadata. And that's it on my side. Now, maybe last slide. It was just a quick take-home message on this analysis. So as a conclusion on that part, we need more conformsTo if we want to increase the validation of bioschemas markup. When we don't have this conformsTo, we are working in FairChecker in a way of suggesting the closest profile by computing a distance between an instance and a profile. Then we would need to target specific communities if we want to improve the quality of the markup. And if we focus maybe also on some typical properties such as URL, alternate name, citation, then we could have a good impact on the quality of metadata.
That's great. I think we've got a quick question from Stefan, and then we'll move on to Ivan.
Yeah. So two quick comments. Number one is that I also did a poor man's harvesting of the live deploys, and I had, I think, a lower number of JSON LDs that I extracted from the pages. Now, I would have to debug what I missed and why I missed them, whether they were not in the head or meta or something like that. So somehow I got the majority, but some embedded the markup in a way that I didn't expect. So that could be something, but if you did the standard compliant extraction, then that's perfectly fine. And a second idea I had was, if we did some of that validation on a regular scale, would you then have a validation badge that we could plonk onto the live deploy pages?
So your suggestion is to store the validation and just to expose a validation report on the website?
Well, ideally on the, so months ago, we had the discussion that we don't have a contact point for all the live deploys to tell them you misspelled creative work.
Yeah.
And we could also, just like the continuous integration on GitHub projects, provide badges for the live deploy pages, so people see which of them are compliant, warning, error, and so on.
Yeah,
I think that might be. I think this might be a good thing to discuss at German Biohackathon as well, because we were talking about how to reach out to communities and tell them how to improve their bioschemas, and maybe some sort of website which displays on a weekly basis the health status of their site, might be good. Marco, you've got a question. If it's quick, we can have it now. Otherwise, let's wait to the end.
So shall we wait for the end, or?
Yeah, I'm just thinking because we're recording this, so we don't want to interrupt the flow of the talk too much.
Let's move to the end. Yes.
Okay. All right. Great. In that case, Ivan, do you want me to slide advance for
Yes.
you? Or? Okay.
Yes, please. It's only one slide.
Okay.
Okay. I will do a quick summary of our project number 7. So the idea was to.
Sorry.
Yeah, no problem. The idea was to just create one large knowledge graph from several resources from different providers. So this is the development from last year biohackathon and last year idea, where we created a aggregated resource based on IDP community resources. But the difference is that those resources were made from single providers, from one more or less developer. So it is quite homogeneous as markup, as implemented markup. And here we wanted to try what would happen if we combined resources from several providers across completely two separate communities that, of course, have some profiles, some connections. So as before, the idea was to create the knowledge graph only from Bioschemas data dumps, and to showcase it with some queries across all the resources, all the aggregated resources, and extend these queries with federated queries if needed. And I will show you when it was needed. So we created the dumps from several sites. The dumps are provided and available on GitHub, and we had to a little bit clean up and adjust some dumps. Most of them are subsets, are not complete dumps, but it is just to see if the idea works. Then we imported all this in a GraphDB instance on the NB node. And we managed to then clean up these data dumps, import them into the knowledge graph, and we managed to generate Sparkle queries that can integrate across all those resources. And we needed to use, in this case, Uniprot Sparkle endpoints to filter out taxons for plant use cases only. We didn't have we didn't know how to do it otherwise, only locally, because we were missing a taxon only knowledge graph. So this is one case of a federated query that was needed to connect or filter, in this case, a little bit the graphs. So we managed to create Sparkle scripts that would solve something like, can you show me compounds in plants or caffeine in the resources, and ideally also caffeine in plants. For example, show me all the resources and all the details about this compound with this INCHI key in plants. This last Sparkle query, I think we still need to figure it out how to do it efficiently, but it is doable. Major issues that we found during this experiment is that a lot of resources are not using sameAs property, which is crucial if you want to integrate multiple resources, because it's the only way to connect a profile, an object to another one, and in this case, in those cases where sameAs was used, it wasn't used exactly as we wanted. So maybe if you have, I don't know, multiple, for example, let's say ontologies, and one resource will use one ontology, the other one would use, I don't know, obo foundry, the other one just persistent URL to another thing, but not both of them. So again, we would have a disjoint graph. So this was one major issue. And then we had, of course, the discussion on defined term, which is mandatory when we speak with things like taxons. And we have a nice issue discussion on GitHub about it. So major actions would be to finalize the report. It started. We started drafting it in Markdown. Then we will move it to GitHub. It would be nice to have some help to, for example, to do this last query. So how can we efficiently filter, for example, a taxon, pick up only plant taxon out of everything? So do we need to go to Uniprot, or can we do it somehow locally? And what to do, and in these cases, when we are forced to do a federated query, how to deal with errors or timeouts, because even Uniprot, which is quite robust, not always produces the result, and also has some timeout errors and stuff like that. So I don't know how to deal. We don't know how to deal with that kind of errors. And then it would be nice to somehow, or not enforce, but at least explain or add examples. But we need to say how much important is the sameAs property, especially if you want to use the markups, so on the consuming part of the project. And of course, we need to agree on a new format for a defined term. So there were several ideas about it and proposals, and yeah, you should see this issue and comment on it. And I think that's it.
Sorry, I forgot to unmute myself. I think that's all the summary slides that we had. The only other thing we wanted to do was to come up with timelines, but I think maybe we should do that after the call in the interest of time. So Marco, let's go back to your question.